Okay, so we proceed to the analysis of indeterminate frames using the moment distribution method. So this time, for this example, we have an example of a frame with no side sway. So as you can see for this frame, we have here a horizontal member CE and a hinge support at joint E. If we are to apply a horizontal force, for example, or a lateral force, for example, we have the 20 kips acting at joint B, acting lateral. That is a lateral load to the frame. Support E will prevent the frame from side sway. So we assume this frame to be a frame with no side sway. So we have unequal stiffness factors for all the members. For example, we have first for column AB and beam BC, we have the stiffness factor to be 4 times EI divided by their corresponding length. Then for span CD and CE, we have the stiffness factor to be 3 times EI divided by the length. So since we have now the stiffness factors, so next to compute, we have to compute for the distribution factor. So we have first, for the distribution factors, we have the distribution factor for member AB to be 0, again, since that is a fixed support for point A. Then we have the distribution factor for member BA is equal to the stiffness factor for member BA. This is divided by the summation of all stiffness factor of joint. We have joint B. So we have, this is the same, what is the stiffness factor for member BA? That is the same as AB. We have that is 4 times EI. This is divided by the length of BA is 15 feet. This is divided by what are the members or span connected to BA. Connected to joint B, we have BA and BC. So BA is the same as 4 EI. This is divided by 15 plus BC, that is 4 EI, the span BC is 18 feet. So what will be the distribution factor for BA? We have that is equal to distribution factor for span BA is equal to 0.545. So that will be our distribution factor BA. The next span, we have the distribution factor for member BC. That is equal to the stiffness factor of member BC divided by the summation of the stiffness factor of all members connected to joint B. So we have for span BC, that is the same as 4 EI divided by the length. For BC, we have 18 feet divided by spans connected to joint B, we have BA and BC. So it's the same as 4 EI divided by 15 for BA and 4 EI. This is divided by 18 for BC. We have the distribution factor for member BC is equal to 1 minus this value. You can use that. That is equal to 0.455. So take note that the summation of the distribution factors for a given joint is always equal to 1. So we may do, since we have BA, 1 minus 0.545 is the same as 0.455, or the same as this value if we are to compute. That is the same as 4 over 18 divided by 4 over 15 and 4 over 18. So it's the same as 0.455. So again, the summation of the distribution factor for a given joint is always equal to 1. Then we have the distribution factor. Distribution factor for member CB is equal to the stiffness factor for member CB divided by the summation of the stiffness factors of the spans connected to joint C. So we'll be having what is CB, or the same as BC. We have 4 EI, the span is 18 feet. divided by, what are the members connected to joint C? We have CB, so it's the same as 4EI divided by 18 plus, we have CD. Okay, CD with this stiffness factor, that is 3EI divided by, the span of CD is 15 feet. Plus, we have CE, the stiffness factor is 3EI over L. So that will be, we have 3EI, the span of CE is 12, we have 12 feet. So we have, this will be the distribution factor for span CB. So it's the same as 4 over 18 divided by 4 over 18 plus 3 over 15 plus 3 over span of 12 for CE. So we have the value of 0.30057. We can have it as 0.331. The distribution factor for span CB. Then we proceed to the distribution factor for member CD is equal to the stiffness factor of CD divided by the summation of the stiffness factor at joint C. For CD, we have this 3EI. This is divided by 15 feet. All over the same denominator as this one for joint C. We have this 4EI divided by 18 plus 3EI, this is divided by 15, plus 3EI, this is divided by 12. Distribution factor for span CD is now equal to we have 0.29, 0.298. And lastly, we may compute for the distribution factor for member CE. So we said a while ago that the summation of the distribution factor for a given joint is always equal to 1. So we can have the distribution factor for member CE as 1 minus the distribution factor for member CB. What is that value? For CB, we have 0.331 minus the other member connected to joint C, we have CD. For CD, we have, so this is for CD, 0.331. For CD, we have 0.298. So we're having the distribution factor for span CE. This is 1 minus 0.331 minus 0.298. So we're having a distribution factor for CE 0.371. Then we will proceed to the last two members. We have the distribution factor for member DC. Take note, this is a hinge support, and that is equal to 1. Distribution factor for member EC is also equal to 1. So this is for a hinge or a pin. So pin support or hinge support, distribution factor will be equal to 0. So unlike for fixed support, that is distribution factor for hinge or pin will be equal to 1, while for fixed support, that will be equal to 0. So those are the values of the distribution factors. Now we are to compute for the fixed end moments. So for the fixed end moments, as you can see, the only loaded span is span BC. So we are only considering span BC if we are to compute for the fixed end moments. Since as you can see we have a 20 kips acting at the joint B, it will not contribute for the fixed end moment. Okay? Or it will not contribute a fixed end moment. So we have the fixed end moment. This is for member BC. As you can see, this is a counterclockwise moment, so assumed to be negative. This is negative the uniform load, L squared, the length squared divided by 12. So it has a span of 18 feet. So we'll be having 5 times, or negative 5 times 18 squared divided by 12. So we have the fixed end moment for span BC. So we have a negative 135 kips foot. So if we have a uniform loading, we will be having an equal moment on the other end. It is a clockwise moment. So we have the fixed end moment for span CB is equal to positive 135 kips foot. So again, since uniformly distributed load, this moment is numerically equal to this moment, but opposite in sign. So we have now the distribution factors, the fixed end moment. So let us tabulate the values for the moment distribution. Okay, so we tabulate our values. The values of the fixed end moments and the distribution factors. So as you can see, again, we have only member BC and CB, the members with fixed end moments. Again, the 20 kips is acting on a joint. If it is acting on a joint, it will not contribute to a fixed end moment. So let us now do the first distribution. So let's say we are to perform up to 5th distribution. So how to so for joint B, as you can see at joint B, we have a fixed end moment for BC, negative 135. So if we have a moment there of negative 135, your moment balance is equal to 135 but opposite in sign. It should be positive 135 kips foot. To balance, I use the opposite sign. So how do we distribute that for BA? We are to use the distribution factors. So under the first distribution, the moment for BA is equal to your distribution factor 0.545 multiplied by positive 135. So we have that value, 0.545 of 135 is, we have 73.575. And the moment for BC is distribution factor of 0.455 multiplied by 135. We have this is equal to 61.425. So we have those values for the first distribution. For BA, we have this is 73.575. For BC, we have 61.425. So that is for joint B. While we are to do the same for joint C. At joint C, we have the moment 135. So let's say for joint C, what will be our moment balance? So let's say for joint C, what will be the value of the moment that will balance? That will be, since we have positive 135, to balance, use the opposite sign. That is negative 135 gives foot. So we are to, for example, we are to compute for the moment for CB. The moment for CB under first distribution, we have its distribution factor 0.331 times the moment balance negative 135, and this is equal to, so we have 0.331 multiplied by positive 135 or negative 135. So it should be negative And we have negative 44.685. So that will be the moment to be distributed for span CB. Negative 44.685. Okay? Then, we are just to do the same, multiply the moment balance to the distribution factors. So we have negative 135 multiplied by 0.298. We have negative, this is negative 40.23. Then last span, we have negative 135 multiplied by 0.371. And that is negative 50.085. Okay, so that is our first distribution. After the distribution, we are to do carryover moment. We are to transfer 1/2 of that moment to the other side. So what is the other side of AB? So again, since this is 0, the other end is, okay, as you can see, the other end is BA, but this is 0. We are to transfer this one, 1/2 of its value to the other end. So 73, we have 73.575 times 0.5. And we have 36. This is 36.788. And we have 73.575 times 0.5 is 36.7. This is positive. Okay, 36.788. So what is the other end of BC? We have, that is CB. So we are to carry over 1/2 its value on the other end. So we have 61.425 times 0.5, and that is equal to, we have 30.713. And the same, what is the other end of members CB? That is BC. So negative 44.685 times 0.5. And we have, this is negative 22.343. Negative 22.343 gives foot. So we have, how about this one? So we have member CD, the other end of member CD is DC. But as you can see, what is support D? Support D is a hinge. You cannot transfer a moment from a fixed support to a hinged support. So we cannot carry over moment on the other end if that is a simple support. The same with CE. The other end of CE is EC. So again, okay, there is a simple support. We are not to carry over moment on that end. So as it is, so again, this is 0, 0, 0, 0, 0. So again, we are not performing first distribution and carryover moment for simple supports. So that will be our carryover moment. So let us now proceed to the second distribution. So second distribution, your distribution factor multiplied by your moment. So that is the same as supposedly 0. Okay. At joint B, we have the remaining moment of negative 343 keeps foot. How to balance that? Use the opposite sign. 22.343. So 22.343 multiplied by the distribution factor 0.545. So that will be positive. This is positive 12.177. Then we have negative 22. This is negative or positive 22. Take the opposite sign to be balanced. 22.343 multiplied by 0.455. And it's equal to positive 10.166. Okay? Then, we proceed to joint C. The remaining moment at joint C is 30.713. How to balance that value? Use the opposite sign. Negative 30.713 to be distributed to all spans connected to joint C. So we are using negative 30.713. This is multiplied by 0.331. And that is equal to negative is equal to negative 10.166 for CB. Okay, negative 30.713 to be multiplied by 0.298. That will be equal to negative. Okay, this is negative 9.152. Then for the last span, okay, we have negative 30.713. This is multiplied by 0.371. This is equal to negative 11.395. Okay, then again, so for endpoints or for supports for CD, that is your distribution factor times your moment, but these values are 0. So that will be our second distribution. So we have to proceed with the carryover moments. So carryover moment. So for the carryover, we are to transfer 1/2 of this value to its other end. So again, we have AB. What is the other end of AB? That is BA, but this value is 0. Then we transfer 1/2 of this value to the other end, BA, we have AB. So what is 1/2 of 12.177? Is equal to 6.089. And then we have the other end of BC is CB. So that is 10.166 times 0.5. And we have that value as 5.083. What is the other end? Well, the other end of CB is BC. We have negative 10. That is the same. Ay, pareho lang naman pala to. So that is the same, but opposite in sign. It will be negative 5.083. Then again, for CD, that is assumed to be a fixed support, not to be carried over on the other end, DC. At support DC, that is hinge support, the same with point E. So again, these values are zeros. Okay, so you cannot carry over a moment from a fixed support to a hinged support. So that will be our carryover moment. Then we proceed to the third distribution. So for the third distribution, we have the remaining moment for joint B of negative 5.083. But for this one, 0 times this value is the same as 0. Remaining moment is negative 5.083. So, how to balance? Use the opposite sign. Positive 5.083 times, we have 0.545. That will be equal to positive 2.77. Then, multiplied to 5.083 multiplied by 0.455. We have 2.313. 2.313. And then we have this one. This is a positive moment. How to balance? Use the opposite sign, negative 5.083. Then distribute using the distribution factors. So you have negative 5.083 multiplied by 0.331. And we have negative 1.682. And then next factor, we have 0.298. That is a negative 1.515. And then we have 0.371 as a factor. And we have negative 1.886. And again, 1 times 0 is 0, 1 times 0 is 0. So just leave it as a dash. That will be our third distribution. After distribution, we proceed to carry over moments. Okay, for the carryover moment, again, so the other end of this value is a 0, so dash. We have half of, what is the half of 2.77? That's equal to 1.385. Then we have the half of BC, 2.313. That is equal to 1 point, sorry, so it should be there. Hindi yan dito. Supposed to be here. Yeah. So we have 2.313 multiplied by 0.5. That's equal to 1.157. So we have 1.157 and half of this one, and negative 1. This is negative 1.682. This is multiplied by 0.5 is a negative 0.841. And again, no distribution for hinge support. 1 times 0 is 0, 0. Alright? So we have to proceed with our fourth distribution. So for the fourth distribution, we have 0 times this value is 0. Remaining moment for joint B is negative 0.841. So we use the positive sign to balance. 0.841 times 0.545. That is equal to 0.458 for this one. Then multiplied by 0.455, you have 0.383. Alright, and this value is positive, so to balance, use the negative. So negative 1.157 multiplied by 0.331 is a negative 0.383. Okay, multiplied by 0.298, we have negative 0.345, and lastly we have 0.371 is negative 0.429. Then again, 1 times 0, 1 times 0. And we have our carryover moment. So we have to transfer 1/2 to this side. 0.458 times 0.5. That is 0.229. Then this is 0. And we have 0.383 times 0.5. That is 0.192. And this one is that is the same, but opposite in sign, 0.192, negative. So no distribution, no carryover moment for these ends. So for CD, CE, and DCN, EC. And then we have our last distribution, the fifth distribution. So we have 0 times this moment is 0. Negative 0.192, how to balance that? Use the opposite sign. 0.192 times 0.545. Positive, that is 0.105. Alright? Then multiplied by 0.455 is equal to positive 0.087. Okay, positive 0.192, how to balance? Use the negative sign, negative 0.192 times 0.331 is equal to negative 0.331. negative 0.064. Then negative 0.192 multiplied by 0.298. This is equal to negative 0.057. And lastly, multiplied by 0.371. We have this is equal to negative 0.071. 0, 0. So we are able to compute for those values up to the fifth distribution. If we have a very small remaining values to be distributed or to be carried over, so you may stop the moment distribution, then do the summation of the moments. So let us do the summation of the moments. So for moment AB, you have that is 36.788 plus 6.089 plus 1.385 plus 0.229. So you have the moment of 44. This is the summation of moments. This is positive 44.491, which means there is a clockwise moment. And then we have next, starting with the fixed end moment, we have 73.575 plus 12.177 plus 2.77 plus 0.458 plus 0.105. So we have this equal to 89.085. Positive. Then for BC, saan na yan? So we have negative. This is negative 135 plus, I'll check kung meron pang memory yung phone. So negative 135 plus 61.425 minus 22.343 plus 10.166 minus 5.083 plus 2.313 minus 0.841 plus 0.383 minus 0.192 plus 0.087. So we have negative 89.085. Then we have for CB, this is 135 minus 44.685 plus 30.713 minus 10.166 plus 5.083 minus 1.682 plus 1.157 minus 0.383 plus 0.192 minus 0.064. This is equal to 115.165. And then CD, that is negative 40.23 minus 9.152 minus 1.515 minus 0.345 minus 0.057. It's equal to negative 51.299. And then last, we have negative 50.085 minus 11.395 minus 1.886 minus 0.429 minus 0.071. So we have 63.866. Negative 63.866. Okay, so we'll be having the moments. Okay, based on this one, we have the moment AB The same as the moment at A is a clockwise moment since it is positive. 44.491 keeps foot. Then for moment BA and BC, we have a clockwise and a counterclockwise. So this is the moment for BA, so negative 89.085 keeps foot. While for the moment for BC is equal to 89.085 keeps foot. And then we have the moment for CB. This is CB. The moment for CB is equal to, this is positive, 115.165 keeps foot. The moment for CB is equal to counterclockwise, negative 51.299 keeps foot. And the moment for CE is equal to negative 63.866 keeps foot. So as a checking, we may check the moment for CD plus CE should be equal to the moment for CB. Negative 51.299. If you were to draw the free body diagram, it should be in equilibrium. Then negative 63.866. So it's the same as 115.65. So again, so we have point D and point E, zero moments since they are hinged. So using those moments, moment at A, you can compute for the support reactions at E and at D. So this will be our example for frames with no side sway. Why is it that we don't have a side sway since we have a lateral support? So if we are to remove this one, if we are to remove member CE, obviously this frame will be prone to side sway. So let's have that for the next example.